All right, good morning, everyone. So before we begin our class, as usual, I would like you to record this note. This is the note for today's class, so please kindly write it down. I'll give you around 3 minutes to write everything down. All right, I think I gave you plenty of time to write down the notes. So we shall begin our lesson for today. All right. So as I've mentioned to you, today my objective is to finish up chapter C7L2. So this is the continuation of what we have learned yesterday. Okay. Yesterday or 2 days ago, 2 days ago, I think. All right. So in this chapter, we will introduce another methods in order to identify the slope and also the deflection of the beam. So just a small recap on what you have learned 2 days ago. So in C7L1, basically what you have learned is you apply the basic differential equation, and also you use the concept of section by section that you have learned in chapter 5, C5L1 specifically, to obtain the moment equation, right? To obtain the moment equation, and then through the usage of the basic differential equation, you'll be able to integrate the equation so that you'll be able to get the slope, and also you'll be able to get the deflection equation. So another recap is you have to remember the boundary condition. So as I explained 2 days ago, for pin support, the only boundary condition that you have is y equals to 0. Roller support also the same, y equals to 0. Meanwhile, fixed support, you must have two boundary condition. Number one is for the slope. Second is for the deflection. And then lastly is the beam continuation, which depends on the situation. Okay, not all the time is the same, but it depends on situation. So for this continuity function, you have to apply the Macaulay's method. If you take a look at this mathematical equation, I don't think you will be able to understand specifically. But nonetheless, we will do the examples later on. We will do the examples so you will understand it further. So this concept is actually you have to apply here, which is the discontinuity function method, whereby moment relationship, there is 4 equations that you need to remember over here. So there is a important information that you must remember at this side. Okay, if the moment in this case is clockwise, okay, is clockwise, then this is the equation. Okay, this is the equation. If the force is pointing upward, then this is the equation. If the distributed loading is pointing upward, then this will be the equation. And lastly, if the triangular loading is pointing outward, this is the equation. All right, you must remember. In other words, for Macaulay method, it is totally opposite direction in what we have learned so far, whereby clockwise is considered as positive, pointing upward loading is considered as positive. Okay, so ME is the moment value, X, you let it be, A is the position of where the load is located. So we will try to do some exercise from our slideshow so that you can further understand how does it works. Open up the slideshow. Function. Video of this. Give me a few seconds. Oh. Okay, so copy that. Okay, so first example. So before I begin with the example, where is my pen? Okay, my pen is in here. So just a recap on the note that I gave you just now. So for positive moment, right? Okay, if the moment is in such a direction, then we will have the equation is m equals to me x minus a to the power of 0. Okay, to the power of 0. And then if you have a point load, okay, point load pointing upward, then m is equals to fe bracket x minus a to the power of 1. Next, if you have distributed loading pointing upward, okay, distributed loading pointing upward, so m equals to we divided by 2 x minus a squared. Lastly, if you have triangle loading pointing upward, then m is equals to m over 6 x minus a to the power of 3. So you can see the pattern over here. It is very easy for you to memorize. So the power increment is from 0, 1, 2, 3. If you notice, right? 1, 2, 3. Meanwhile, all you have to remember is the only thing that in front of the Macaulay bracket. This is what we call as Macaulay bracket. Okay, this is what we call as Macaulay bracket. All you have to do is just remember the coefficient in front of the Macaulay bracket. So the formula is not that very hard to remember, but if you practice more, you should be able to familiarize yourself. Now, before we begin with this example, there is another thing that I want you to practice first, which is to integrate the Macaulay bracket. Okay, is to integrate the Macaulay's bracket. So let's say if you have an equation, x minus 3 power 2. As I mentioned to you, this bracket, it is named as the Macaulay's bracket, right? So if you want to integrate this, you treat this entire thing as one unknown, okay? One unknown. So if you integrate this, then you will have x minus 3 cubed divided by 3. Do you understand what I'm talking about? You treat it as one single unknown. Don't expand it. If you expand it, then you do it wrongly. This is the concept of Macaulay's bracket. You must treat it as one single unknown, and then you continue to integrate it. Hello, anyone? Do you understand what I'm talking about?
Yes.
Okay, what about if I give you one simple example? 2x minus, let's say, minus 4 squared. So if we integrate this, what do you get?
2 over 3x minus 4 cubed.
Cube divided by?
3.
Yes, correct. This is how you should integrate if you are applying Macaulay's bracket. So in this case, let's say if I further integrate, then this will become x minus 3 to the power of 4. Then it will be 3 multiplied by 4. Okay. This is how you further integrate the Macaulay's bracket. Any question?
No. No question.
No. Okay, good. So I shall erase this practice, this simple practice. So I will edit this because I need some spaces to do the calculation for this example. All right. So as usual, first step, you must draw your free body diagram. First step, draw free body diagram. So this is your free body diagram, and take a look at point A. So you must be careful always. Point A, this is a roller support. So obviously you must have AY. Meanwhile, point B, this is a pin support. So obviously you must have BY and also BX supposedly. However, if you take a look at this free body diagram, I don't think there's any value in BX, so you can leave it behind. Okay, so you can leave it, because if you calculate summation of fx equals to 0, you'll be able to see that your bx is also equals to 0. So second step, as usual, equilibrium equation. So let's say if I take the summation of moment at point A equals to 0. So I can see that there is 1.5 kilonewton meter, which is already in clockwise motion. So therefore, this is negative 1.5. Agree? You don't have to multiply by perpendicular distance or whatsoever, because it's already in moment, right? It's already in moment. So directly just plug out the value. Next, I will have this distributed loading. To ease my calculation, I will divide it into two. One is for the triangular part, one is for the rectangular part. So for the rectangular part, if you have a rectangular distributed loading pointing downward, and then if you treat point A as a point where you have fixed it or nailed it, then this distributed loading will cause a clockwise motion. So therefore, this is negative 3 times 3, right? Because you need to have the height of the rectangular multiplied by the length of the rectangular. So 3 times 3. So far, so good.
Yes.
Followed by,
Yes.
you have to multiply with the perpendicular distance to point A. So the perpendicular distance of the rectangular loading is actually half of the rectangle, right? So 3 meter plus 1.5 meter. That's why you will get 4.5 meter. Next, you have this triangle. So this triangle also pushing downward. So obviously it will cause a clockwise motion. So the area of the triangle, which is 1 over 2 times 3, and then also times 3, because this is the height of the triangle over here. This is 3, this is 3, right? Must remember this. This is the basic thing that you have learned in chapter 1. Next, what is the perpendicular distance of the triangle? So you know that the triangle, the perpendicular distance must be 2 over 3, and then this side is 1 over 3, right? So if it is at here to point A, so you have to calculate where is the point. So it's supposed to be 2 meter, isn't it? Do you agree?
Yes.
Okay. So the centroid of the triangle to point A, which is 3 meter plus 2 meter, therefore you'll be able to get 5 meter. Lastly, you have this By pushing upward. So obviously it will cause anti-clockwise motion. So this is positive By. And then the perpendicular distance to point A is 6 meter. Nothing else, I put it equals to 0. So therefore By is equals to 10.75 kilometer. Next, I need to calculate my AY. So I will use summation of forces in the Y direction. So summation of forces in the Y direction, Fy equals to 0. So therefore I will have AY minus the rectangular loading, 3 times 3, right? Minus the triangular loading, 1 over 2 times 3 times 3. And then plus by, which is 10.75 equals to 0. So my ay, I will get equals to 2.75 kilonewton. Can you get this value?
Yes.
Okay, good.
Yes.
So next step is, before you want to apply the Macaulay function or Macaulay bracket, it is very important for you to update your free body diagram. So allow me to delete all these things first. Okay, I will leave the AY behind because I need that information. So after we calculate by using the equilibrium equations, we have found that at point A, this is 2.75 kilonewton, right? 2.75 kilonewton. Meanwhile, By, this is 10.75 kilo. So, if I want to apply Macaulay's function, this is how you apply it. So I will stick to it. I need to split this into two. Right? So this is 3. This is 3, the height. So you know that in C7L1, in order for you to develop the moment equations, you have to see how many sections. That's number one. And then second is you need to apply the basic differential equation. And then you slowly integrate it so that you'll be able to get your slope and also your deflection equations, right? So the advantage of Macaulay's method is you don't have to do section by section. You can straight away develop your moment equation in one single equation. Doesn't matter how many sections you have. That is the advantage of Macaulay's method. So how is it? This is how you apply it. So M is equals to, you have to take a look one by one. So from the left-hand side, take a look. Number one is you have a point load pointing upward, 2.75. Among these four equations, which one is the closest one?
The second equation.
The second equation. So Fe is representing the load itself. So therefore 2.75 bracket x minus, as I mentioned to you, A is the location where the load is. So according to this free body diagram, where is the position of your 2.75 kilonewton?
0.
0, exactly. So power to 1. Next, you have this 1.5 kilonewton meter moment, which is the closest one among the four equations.
First.
First one, right? First one. So since this is already in clockwise motion, so it's obey, right? It is obeying the, the direction of this equation, isn't it? So therefore, you have to put plus. What is your ME? Which is 1.5. X minus, as I mentioned to you, A is the location where your loading or moment is. So based on this free body diagram, where is the location of 1.5?
3.
3. So power to 0. So far, so good.
Yes. Yeah, good.
Okay, good. Let's proceed. Next, you have this rectangular loading. This rectangular loading is pointing downward. Okay, nonetheless, before you want to apply the Macaulay's method, you have to see first among these four equations, which one is the closest for the rectangular part?
Third one.
The third one, right? The third one. So if you take a look at the table of this rectangular Macaulay's function, positive should be pointing upward, right? However, ours is pointing downward. So therefore, you have to put negative. What is your WE? WE is actually the height of the rectangular loading, which is 3 divided by 2. X minus A is the location where the loading starts. Okay, where the loading starts. Later on, I will explain to you why you have to do offset method for distributed loading. okay, for distributed loading. For now, A, you have to remember, for distributed loading, this is the location of the starting point of the loading. So where is the location of the starting point of the loading?
3.
3. Where? Next, you have this triangular loading, right? The triangular loading. So for the triangular loading, of course, the closest one is the fourth equation, right? The fourth equation. So the fourth equation is M. What is M? Based on the note that I gave you, take a look at the note that I gave you. M is the gradient of the triangular load, isn't it? Gradient of the triangular load. So if we have this triangle, this is 6. Okay, let's say this is the line. So the location of this is actually 3, 3. Agree? And then the location of this is 3, 6. Agree? I treat it as a partition plate. Do you agree or not? This position is 3, 3. This position is 3, 6. I mean 6, 6, right? Sorry. 6, 6. Do you agree?
Yeah.
Okay, agree, right? So according to the gradient formula, so M is equals to y2 minus y1 over x2 minus x1, isn't it? This is how you find the gradient, right?
Yes.
So M is equals to y2, which is 6 minus 3, divided by 6 minus 3. Therefore, your M is equals to 3, isn't it? Sorry, your gradient is supposed to be equals to 1, isn't it?
Yeah.
1, right? Let me write it properly. Sorry. Write it properly. Equals to 1. Because 3 divided by 3, you will get 1, right? You will get 1. However, if you take a look at our triangular loading, it is pointing downward. So it is against the original Macaulay's function. So therefore, you have to put negative. And what is your M? Your M is 1 divided by 6 x minus A. As I mentioned to you, for distributed loading, A is the starting point of the loading. So the starting point of the triangle load is actually 3. So Q. Lastly, you have this 10.75 kilonewton, which is pointing upward. So obviously, this is the closest one with the second equation. So simply plus 10.75 bracket x minus the location of the loading, which is 6 to the power of 1. This is your equation. This is your moment equation. So you don't have to do section by section. This is how easy Macaulay method is. Any question?
No.
So I have a question for you. You know that A is the location of the loading for moment and point load. Meanwhile, for the distributed loading, A is the starting location of the loading. So what is this X for then? What is this X for? So anyone can answer me? What is that X for? Anyone can try to guess what is the purpose of this X? Anyone?
The distance from the other end.
Nope. When you do section by section, what is this X for?
The unknown lengths of each section.
Um, I would say that your answer is 50% correct. The answer is actually X is the specific location of your analysis. So in in C7L1, right? After you develop your, what do you call the slope and also deflection equation, right? Let's say the question asks you to find the deflection and also the slope when x equals to 2. So you have to substitute x equals to 2, isn't it? There is a specific location of your point of analysis, isn't it? Correct or not?
Yeah.
Right? So x is the specific point of your location that you want to analyze. So if you try to take a look, this specific part, x minus 6, right? X minus 6. Another thing that you must remember for Macaulay function, apart from how do you integrate this, second is to identify whether it should have a value or not. This is very important for Macaulay's bracket. So listen carefully. Macaulay bracket is not a common bracket. You cannot expand it and you cannot take the value directly. So let's say if x equals to 0. So just focus on 10.75 x minus 6 power 1. The rest I don't want to talk about first. I want you to focus on this first and learn how to use the Macaulay bracket. Let's say if x equals to 0. So you will have 10.75, 0 minus 6, isn't it? Do you agree?
Yeah.
So 10.75 inside the bracket, this is negative 6, right? Agree?
Yeah.
According to the concept of Macaulay's bracket, inside the bracket cannot be negative number, cannot be 0. If you have these two things happen, the final answer for Macaulay bracket will be equals to 0. So therefore, this will become 10.75, 0, power 1. So 0, 0, you will get 0. So do you understand what I'm talking about or not?
Yes.
Okay. Let's say if I pick this and then x equals to 4, let's say. So 1.5, 4 minus 3 inside the bracket. So 1.5, you will get 1, isn't it?
Yeah.
So if it is positive value, so you can convert it to its original value, which is 1. That's why you can see the bracket changes already. From this diamond bracket becomes curved bracket. Did you see the difference between these two?
Yeah.
So 1.5 times 1, your final answer is 1.5. This is how you apply Macaulay's bracket. Okay, this is something that you never learned in your high school, but you will use it someday in your engineering mathematics. So I don't know whether you have been exposed to this or not, but if it is not, then good thing for you. Right now, you have to understand how do you use Macaulay's bracket. Any question before I proceed?
Yeah, the power outside the bracket. We just like for cubed, for example, 1/6 x minus 3
You will
uncubed.
apply the cube normally.
Okay.
Like for example, okay, for example, let's say if we pick this. Okay, so 3 over 2, right? 3 over 2. Let's say I remain x equals to 4. So 4 minus 3, right? Square, isn't it? So 3 over 2 inside the Macaulay's bracket, this will become negative 1. Sorry, 1, isn't it? Positive 1, right?
Yeah.
Am I right? Let me write it properly. So this is supposed to be equals to 1, isn't it? So since it is positive value inside the Macaulay's bracket, so you can do it normally. Square. So 1 square equals to 1, isn't it?
Yes.
So 3 over 2 times 1 will get 3 over 2 anyway. So you have to apply the power normally. Is it okay?
Yeah.
Okay. Any other question that you want to ask me before I proceed? Any question? This is very important in this chapter. You have to know how to use the Macaulay's bracket. Anyone have any question? Can I proceed? Anyone? Is it okay? Can I proceed?
Yes.
Okay. Okay, thank you. So delete all this. Make sure you remember how to use the Macaulay's bracket. It is very important in this chapter. If you cannot understand how do you use the Macaulay's bracket, so basically you will have a hard time for this particular chapter. Macaulay bracket is not that hard. It's very easy. Okay, so back to our equation for this part, right? For this part, you will notice that this equation, I can actually simplify it. I can simplify it and my equation will become m equals to 2.75 x minus 0 to the power of 1 plus 1.5 x minus 3 to the power 0 minus 3 over 2 x minus 3 to the power of 2 minus 1 over 6 x minus 3. I can cancel this part. Why? Anyone can answer me? I've explained so much. Inside the bracket must be positive value. If you have negative value of 0, then Macaulay would treat it as 0 directly. So why I can eliminate that part? Anyone can answer me? I'm testing your understanding right now.
Because
Why I can delete that part? Okay, 6 minus 6 equals to 0. Okay. Almost full answer, but I want a full explanation. Why? Why? The beam max length is 6. Okay. I will give you 80% correct answer, but I want a full explanation. Why?
point B acts at exactly x equal to 6. Not less, not more. Right.
85% correct, but I want a very specific explanation. Why? As I explained to you, this x representing the specific point that you want to analyze, isn't it? Let's say x equals to 0. Let's say x equals to 1, x equals to 2, 3, 4, 5, and 6, isn't it? Right? Am I right?
Yes.
Okay, if x equals to 0, what happened to this part? If the question asks you to find x equals to 0, what happened to this part?
It becomes 0.
Yes, because 0 minus 6, you will get 0, isn't it?
Yeah.
Because of the Macaulay's bracket rules, right? Okay, let's say x equals to 3. So 3 minus 6, you will get negative 3. So in the end, you will get 0 also, right?
Yes.
Okay, what about x equals to 6? So 6 minus 6, you will get 0 also, isn't it?
Yes.
So this part will be forever 0. Do you agree?
Yeah.
Therefore, you will be able to eliminate that particular part. So this is why I can simplify my equation into this format. Any question?
No.
No, huh? If there is no question, then we can proceed to the next example. So after this example, I will allow you to rest for a while. Okay. So we go to the next part. So now I hope you can understand how to use the Macaulay's bracket and also how to apply the Macaulay's function. This is what we call as Macaulay's function. Okay, Macaulay's function. Now, I would like to explain again. Just now I mentioned about the distributed loading, these two parts. Okay, for these few hours, I mean for the first hours of our lecture for today, I really want to emphasize on the fundamental first. So please listen carefully. If you do not understand this part, then most likely you will not be able to understand the rest of the part. So if you notice that just now at the start of the lesson, I mentioned that for distributed loading, A, this one, the A, okay, the A is actually the location of the starting, the starting point of the distributed loading. So let's say if I have a load like this, okay, I will use different color. Okay, let's say if I have a loading like this. Okay, let's say this is the length of the beam. This is 2 meter. This is 3 meter, let's say. And then the height of the rectangle, let's say this is 3 kilonewton per meter, right? So if you want to apply your Macaulay's function, obviously this is pointing downward, isn't it? So it should be negative 3 over 2 x minus 0 squared. Do you agree?
Yes.
Right? However, if you apply this Macaulay's function, it will treat that this entire loading will begin from the starting point until the end. It will treat it like this. But in reality, your loading only stops at x equals to 2, isn't it?
Yeah.
Therefore, you have to do offset loading, whereby you have to apply this loading. So this loading is pointing upward, isn't it? So plus 3 over 2 x minus 2 squared. When you apply this, you will be able to cancel this part. You will be able to cancel this part. The only left is this part. Do you understand what I'm talking about?
Yes.
Okay, except for Yoda. Anyone else who doesn't understand? Do you understand what I'm talking about? You have to apply this. Because the concept of distributed loading for Macaulay's function, it will treat that particular loading will start until the end. Because you can see there's only A over there. Right? The equation didn't request you to input what is the end loading, isn't it? X minus A. A is the starting point of the load. There is no input for the where is the point that the loading stops, isn't it? So you must apply the offset loading in this case. If you apply the offset loading, then you can cancel this part. So the only left is this part. This is another very important concept for Macaulay's method. Any question before I proceed? The rest, any question?
No, doctor.
Okay, no. So I shall continue with our next example. So with that, I hope that you can fully understand now how do you apply Macaulay's method. All right, so let's go to this equation. Okay, determine the equation of the elastic curve for the cantilever beam shown. EI is constant. Okay, EI is constant. So I cannot delete the answer at the bottom. It's okay, never mind. We can do it by our own. So in this part, you can see that all the information is already given. You have the reaction at Y. You have the reaction of the moment. Everything is already complete. So straight away, let's say if we want to do the Macaulay's function first, okay? So as usual, actually, first step, you have to draw free body diagram, isn't it? Draw FBD. Am I right?
Yes.
Okay, second step, you have to apply equilibrium equation, right? right? This is the standard procedure. So you can see that the free body diagram is already complete. The equilibrium equation is not needed because you have found that this is 52 kilonewton, this is 28 kilonewton meter, right? So you don't have to do equilibrium equation. So this question is super kind, right? This question is super kind. So in your test, impossible, the question will be so kind. So step 1, draw free body diagram. Sorry, I accidentally deleted it. Draw free body diagram. Second part, you have to do equilibrium equation. And this question is so kind, you can skip step 1 and step 2. So, step 3. Usually, I will ask you to update your free body diagram. Still remember in the previous example, this one?
Yes.
This example, I ask you to update, right? After you have calculated your equilibrium equation, you have to update your free body diagram with the values, right?
Yeah.
Okay, remember that. So in this case, I don't have to update because the free body diagram is already completed with all the updated value. So step 1, step 2, and step 3, I can skip directly. So I don't have to waste my time doing it again. So I can go for step 4. In this chapter, step 4 is Macaulay's function. Okay, Macaulay's function. Directly, m equals to what? Straight away develop your moment equation. So according to this, number 1, 52 kilonewton pointing upward. So just to recap on what you have learned for the Macaulay's equation, you can try to memorize it right now. No need to memorize actually. Just I would say just understand is more than enough already. So for moment, it must be clockwise, right? The direction. And then the equation will be m equals to me bracket x minus 0 to the power 0, isn't it? It is very easy to remember. For a point load, it must be pointing outward. So m equals to fe x minus 0 to the power of 1. You can see the increment of power. Next, if you have a distributed loading pointing outward, so m equals to we divided by 2 x minus a squared. Lastly is the triangular loading. M equals to small letter m divided by 6x minus a cube. It's very easy to remember. Okay, very easy to remember. Practice it from now. So, focus on the 52 kilonewton. This is pointing upward. So obviously I have to apply the second equation, isn't it? Since it is already pointing upward, so it obeys the direction of the Macaulay's function. So this is 52, right? Isn't it? 52 x minus what?
0.
Y?
Let's add 0, I think.
Because not x at 0, because the loading position is at x equals to 0. Be specific. Okay. Next, I have this 258 kilonewton moment, which is in anti-clockwise. So therefore, I should put
Negative.
negative 258 bracket x minus what?
0.
0. Why?
Because the loading is at x equals 0.
Yes, correct. So you must understand that. Next, I have this. I would like to focus all the moment and point load first. Next, I have this 50 kilonewton meter, which is already in clockwise motion. So therefore, it is
Positive.
positive 50 x minus
5.
5, correct. Power to 0. Next, 12 kilonewton, pointing downwards. So therefore, this is negative 12 x minus
9.
9. All right. Bracket to the power of 1 because I'm using the second equation. Lastly, this is the rectangular loading. So this is pointing downward. So therefore, it is negative 8 divided by 2, right? Because I am applying the third formula. And then mark out this bracket, x minus, where is the starting point of this loading?
X equals
0. Okay, 0 square, isn't it? Am I right?
yes.
However, don't forget, if you have a rectangular loading, the formula will treat it as if it will up until the end. So I have to apply offset loading. So the height of the rectangle is supposed to be the same, isn't it? If upstairs is 8, the bottom must be 8, right? In order for you to cancel each other, isn't it?
Yes.
So this is plus 8 divided by 2. X minus what?
5.
5, correct, square. This is your complete equation. So can I simplify this equation?
Yes.
Which part I can simplify? I can remove?
Minus 12 x minus 9.
Exactly. For this part, I can remove it because this will forever 0. Okay, it will be forever 0. So my equation, the only left is m equals to 52 x minus 0, 1 minus 258 x minus 0 power to 0 plus 50 x minus 5 power 0 minus 8 divided by 2 x minus 0 square plus 8 over 2 x minus 5 square. Any question? Any question?
No.
Okay, so I need another space. Okay, I will do it here. So step 5. Okay, I will rewrite the equation. It's not that we develop. M is equals to what again? Can you repeat again? Then never mind. I'll just flip it over. 52 x minus 0 to the power of 1. Then negative 258 x minus 0 to the power 0 plus 50 x minus 5 plus 50 x minus 5 to the power of 0. What else? Minus 8 divided by 2 x minus 0 square plus 8 divided by 2 x minus 5 square. So far so good. Did I do any mistake? No, right? 8 divided by 2 x minus 0 square plus. Correct, right? So far? Did I do it wrongly or anything? No, right?
Correct.
Correct, right? Okay. So step 5, apply basic differential equation. So you have learned it before in previous part, C7L1, EI d square y dx square equals to the moment equation, right? Isn't it? So what is your moment equation in this case? Therefore, it will be very simple. EI d square y dx square is equals to the entire equation. 52 x minus 0, 1 minus 258 x minus 0 power 0 plus 50 x minus 5 to the power of 0 minus 8 divided by 2, x minus 0 to the power square plus 8 divided by 2, x minus 5 square. Any question? I just direct apply. Any question?
No.
Okay, so step 6. Integrate one time and apply boundary condition if it is available. So we integrate one time, so this one will become EI theta, right? EI theta equals to 52 x minus 0 to the power of 2 divided by 2. Agree?
Yes.
Minus. Okay, actually, inside this bracket, it's okay, never mind. I don't want to make you confused. So this leave it be. I think this is better. Because you are not familiar yet, so it's okay. So this one will become 258 x minus 0 power 0 plus, I mean power 1, sorry. Because you have to integrate it. Power 1, right? Plus 50 x minus 5 to the power 1 also, right? Integrate, right? Integrate. Minus 8 x minus 0 cube divided by 2 times 3. Agree?
Yes.
Plus 8 x minus 5 cube. So this is also 2 times 3, right? So we want to make the equation simple. So 52 divided by 2, you will get 26, right?
Yeah.
Okay, let me ask you a very logic question. X minus 0 squared. Anything, it will become x squared, isn't it? Because it will minus 0 forever, right? So can I simplify into this part?
Yeah.
Can, right? So it will be more simple. So x squared minus 258 x to the power of 1 plus 50 x minus 5. Okay, this one I cannot simplify anymore because I need that x minus a divided by 2. I will get 4, right? So I will get 4 x minus 0 cube divided by 3 plus 4 x minus 5 cube divided by 3. So far, so good. This is my slope equation. But we haven't completed it yet, right? Because we have to apply C1, remember? Because you integrate, right?
Yeah.
So you have to apply C1 plus C1. And then you have to apply boundary condition if it is available. So in this case, do you have boundary condition? Do you have boundary condition for this question?
Fixed support, right?
Yes,
So
fixed support, correct?
it's a t to 0.
Yes. So therefore, when x equals to 0, theta equals to 0, right?
Yes.
Am I right? Am I right?
Yes.
So therefore, EI 0 equals to 26 0 squared minus 258 0 to the power of 1 plus 50, 0 minus 5 power 1 minus 4, 0 minus 0 cube divided by 3 plus 4, 0 minus 5 cube divided by 3 plus C1. So my C1 equals to 0. This one is 0, 0, 0, 0, 0, 0. Why everything is 0? Anyone can answer me? By now you should understand why is it 0.
Either 0 or negative in the Macaulay bracket.
Yes, because inside the Macaulay bracket, you can see this is 0, 0, this is -5, this is 0, this is -5. So all the values inside the bracket is either negative or 0. So according to Macaulay's bracket concept, if it is negative or 0, then directly everything will become 0. That's why C1 is equals to 0. Any question?
No.
No, eh? Okay, let's proceed. So step 7. Integrate second time and apply boundary condition. So now my latest equation is I theta equals to 26x squared minus 258 x to the power 1 plus 50 x minus 5 power 1 minus 4 x minus 0 cube divided by 3 plus 4 x minus 5 cube divided by 3. Why I didn't put plus C1 anymore?
C1 0.
Because it's already equal 0, right? I found it, isn't it? So no need. So therefore, if I integrate it, then it will become EI y. Right? EI y 26 x cubed divided by 3 minus 258 x squared divided by 2 plus 50 x minus 5 squared divided by 2 minus 4 x minus 0 power 4 divided by 3 times 4 plus 4x minus 5 power 4 divided by 3 times 4 plus C2. So EIY, I need to simplify it. So 26x cubed divided by 3 because it will be improper fraction anyway. 258 divided by 2, you will get 129. So 129 x squared minus, so 50 divided by 2, you will get, sorry, positive. 50 divided by 2, you will get 25. X minus 5 squared. Okay. Minus, so this one 4, cancel 4, you will get x minus 0 to the power of 4 divided by 3. Same goes to this. 4 and 4 can be cancelled. Plus x minus 5 power 4 divided by 3 plus C2. Did I get right so far? I didn't do any mistake, right?
No.
Okay. So I have another boundary condition for this case, which is y, right?
Yes.
So when x equals to 0, y equals to 0. This is due to the fixed support. This is also due to fixed support. So I will label it so that you can understand it, so that you can do your revision by your own. Why when x equals to 0, y equals to 0? It is because of the boundary condition of the fixed support. Why x equals to 0, theta equals to 0? Because it is the boundary condition for the fixed support as well. So now EI 0 equals to 26, 0 cubed divided by 3 minus 129, 0 square plus 25, 0 minus 5 square minus 0 minus 0 power 4 divided by 3 plus 0 minus 5 to the power 4 divided by 3 plus C2. Once again, this is 0, 0, 0, 0, 0, 0. So your C2 is equals to 0. Step 8. Finalize slope and deflection equation. So you have EI, okay, never mind, straight away write it. Theta is equals to 1 over EI. Get 26x squared minus 258 x to the power 1 plus 50 x minus 5 power 1 minus 4x minus 0 cube plus 4x minus 5 cube divided by 3. This is my slope equation. For my deflection equation, y equals to EI. 26 x cubed divided by 3 minus 129 x squared plus 25 x minus 5 squared minus x minus 0 to the power 4 divided by 3 plus x minus 5 to the power 4 divided by 3. This is my deflection equation. So we are done with this question. Any question?
No.
So far so good? Is it okay?
Yes, Doctor.
Yeah.
Okay, if it is okay, then you can rest for 5 minutes. Come back at 9:21. We will continue the next example. But if you want to proceed with your current momentum, you are free to do so. You can go for the next question. I don't really mind. You can try this if you want. Okay, we shall continue with our lesson. 29, 21. So we go to the next example. Okay, next example. Wait. So determine the displacement at C. So if you can see, displacement means that you have to identify what is the deflection, right? Deflection. And also the slope at A. Okay, the slope at A. So you have two things that you need to solve. All right. So based on the question, based on this slide, the slide already helped you to draw the free body diagram, number one. And then the slide also already helped you to calculate the equilibrium equation. And the slideshow also help you to update already your free body diagram. So you can skip all these three steps. So you can directly go to step number 4, which is Macaulay's function. So M is equals to, I will focus on the point load first. So 550 kilonewton already pointing upward. So therefore, this is positive 550 x minus 2 to the power of 1. Agree? This is the formula, right? Agree?
Yes.
Next, I have this point load 25 kilonewton downward, so negative 25. X minus 2 plus 3, 5 to the power of 1. Agree?
Yes.
Okay, next, I have this distributed loading. Okay, this distributed loading. So, negative 150 divided by 2. All right, 150 divided by 2. X minus 0, because the starting point of the loading is at 0 squared. And then, since if I have this formula, it will treat it until the end, right? Until the end. The rectangular loading. But the reality is, I have a small triangle at here. But if you are smart enough, you have two ways. Number one is, you do the offset for the square part, and then you put the triangle. Or, you directly minus like this. Minus 50 divided by 6 x minus 2 cubed. Because why? This is the triangular loading, right? It is also equal to such, right? It is the same thing, isn't it? Can you imagine that?
Yeah.
Okay, but nonetheless, this is just for illustration. No matter how, this is the original one, right? So you need to get the gradient. So the gradient is actually 150 minus 0 divided by 2 minus 3, isn't it?
Minus 5.
Oh, minus 5, sorry, thank you, minus 5. So M equals to 150 divided by 3, right? Divided by negative 3, right? So you will get negative 50. Am I correct?
Yes.
So that's why this is negative 50. This is the small m. You understand what I'm doing, right?
Yeah.
Okay. So you have two ways, up to you. Either you want to do the offset for the rectangular, and then you add this part, also can. It is not wrong. I'm not saying that it is wrong. But you can also do it in what I'm trying to do. It is also the same. Doesn't matter. Okay, any question before I proceed?
No.
No.
Okay. Next is this equation I can simplify further. Which part I can remove?
$25.
X minus 0. Make it
25
only X.
x minus 5, correct. Because this part, it will be forever 0. So my equation will only left a very short one. 550 x minus 2 power 1 minus 150 divided by 2 x minus 0 squared minus, so minus minus, you will get 50, right? Plus 50 divided by 6 x minus 2 cubed. So that's why if you are smart enough, you have a very short equation. But I'm not saying that you are wrong. If you are not able to imagine it, it is okay, right? If you do the triangle, I mean, if you do the rectangular first and then the triangle, most likely you have two more or maybe one more component at the back, right? But it's okay. You are not doing it wrongly also. Just continue. You will get the same answer in the end. Okay, so step 5. Apply basic differential equation. So EI d square y dx square is equals to 550 x minus 2 power 1 minus 150 divided by 2. You will get 75, isn't it?
Yeah.
Okay, so I can simplify it. Plus 50 divided by 6 x minus 2 cubed. So step 6, integrate one time. And apply boundary condition if available. Okay, available. So EI data equals to 550 x minus 2 square divided by 2 minus 75 x minus 0 cube divided by 3 and then plus 50 x minus 2 power 4 divided by 6 times 4 plus C1. So this one will become 550 divided by 2. You will get 275, right?
Yes.
Then 75 divided by 3, so 25, 25, 25. Okay, so negative 35. Correct or not? X minus
Yeah.
0 cube plus, so 50 divided by 6 times 4. 6 times 4. And 24, so 50 divided by 24. I will get 25, I think. 25x minus 2 to the power of 4 divided by 12, if I'm not mistaken. Can you get this?
Yeah.
Okay. So this is the equation, right? So can I apply boundary condition in this case?
No.
No, correct. Because there is no fixed support, right? There is no boundary condition whereby your theta is equal to 0, right? So cannot. So therefore, we have to go for step 7. No choice. Step 7, integrate second time. And apply boundary condition. Boundary condition. So EIY will become 275 x minus 2 cube divided by 3. Minus 25 x minus 0 to the power of 4 divided by 4 plus 25x minus 2 to the power of 5, right? Divided by 12 times 5 plus C1x plus C2. Am I right?
Yeah.
Okay, good. So 25 divided by 4. Let me do it at the bottom. So EI Y. So 275 divided by 3, I will leave it be. So 275 x minus 2 cubed divided by 3 minus 25 divided by 4. So I will get 6.25 x to the power of 4. Right? Because x minus 0, I will get x only, right? Inside the multiplier bracket, isn't it? Plus, so 25 over 12 times 5. So I will get 25 divided by 5, I will get 5. So 5 x minus 2 to the power of 5 divided by 12 plus C1x plus C2. Am I right? Any mistakes so far? No, right? I think so, right? Okay, right?
Yeah.
Okay. So I have two boundary conditions, so we apply one by one. So when x equals to 2, y equals to 0. This is due to the roller, right? Due to the roller support, right? X equals to 2, y equals to 0 due to the roller support, isn't it?
Yes.
Okay, so EI 0 equals to, I'm sorry, equals to 275 2 minus 2 cubed divided by 3 minus 6.25 2 to the power of 4 plus 5 2 minus 2 power of 5, right? Power of 5 divided by 12 plus C1 2 plus C2. So this one will become 0. This one will become 0. However, 6.25 to the power 4 is not equal to 0. This one becomes 0. So 0 equals to 2 to the power of 4. How much do you get?
16.
How much?
16.
16. Okay, so 16. So 16 multiplied by 6.25?
100.
Yes,
100.
100.
100. Okay, so negative 100, right? Plus 2C1 plus C2, isn't it? So 2C1 plus C2 equals to 100. Never mind, if you see this case, this is equation number 1. don't be panicked. All of you, whenever you see unknown, you will get panicked. Whenever you see such a case, obviously you have to make it as question number 1. You cannot do it anymore. This is very logic. Next, when x equals to 5, y equals to 0. This is due to the pin support, boundary condition of the pin support. So EI, 0 once again, 275. Now it is 5 minus 2 cubed divided by 3 minus 6.25, 5 to the power of 4, and plus 5, 5 minus 2 to the power of 5 divided by 12, plus C1, 5, plus C2. So this is 0. Okay, try to do it, calculate it. So 275 times 3 cubed divided by 3. 275 times 3 cubed divided by 3. I'll get 2475. 475 minus 5 to the power of 4. 5 power of 4 and 6.25. 3965. 5. So 3 to the power of 5 times 5 divided by 12 plus 1.25 plus 5C1 plus C2. 2475 plus minus 3906.25 plus 101.2. So I will get calculator drop. So I will get 0 equals to negative 1330 plus 5C1 plus C2, right? So therefore, if I rearrange the equation, then I will have 5C1 plus C2 equals to 1330, equation number 2. Can you get it?
Yes.
Okay. So those simultaneous equation, just press your calculator, do the simultaneous equation. I will get my C1 equals to 410. C2 equals to negative 720. Okay, press your calculator. Press your calculator, you will get your C1 and C2.
Ya, Dr. Sam.
Good. Thank you. So my final equation will be, I don't have enough space. I can delete this part because I think you have done this anyway. In this part I can delete this part. Okay. This part also can be deleted. So I have enough space to write. Okay. So my final equation will be EI theta for theta equals to 1 over EI bracket what is it? 275 x minus 2 square, right? 2 square minus 25 x to the power of 3, right? Then plus 25 x minus 2 to the power of 4 divided by 12 plus C1x. So what is my C1? 410x. Correct, right? Did I do any mistake?
Only
Am I right so
410,
far?
right? No 410x.
Which one? Oh yeah,
The final sum.
410 only. No x, right? Sorry, yeah, correct. 410, correct. Okay, 410 only. Yes, you are right. 410 only. Okay. Then next is y. Okay, y is 1 over EI 275 x minus 2 maka bracket 3 divided by 3 minus 6.25 x to the power of 4 plus 5 x minus 2 to the power of 5 divided by 12 plus 410x minus 720. Am I right?
Yes.
Okay, good. So what was the question again? The question asks us to find the displacement at C. So at C, where is at C? Okay, C is at here, right? So which equation you have to use? Theta or y?
Why?
Y. Okay, so displacement at C. Whereby x, am I right? Am I right?
Yes.
Okay. So y is equals to 1 over EI. So let's say if we substitute 0, 0 minus 2 inside a bracket is negative. So this part becomes 0. This part also 0. This part also 0. 410 multiple 0 also 0. So you only left negative 720. So your final answer is negative 720 over EI. Okay, what about the next question is slope at A. Slope at A. At A, which is at here. So which means slope at A, which is x equals to 2. So theta equals to 1 over EI. Okay, so this one we no longer, I think still can. So this one cancel. So you only left minus 25, 2 cube. So 0 minus 2 cancel also, plus 410. This is the only thing left. So theta equals to 2 cube multiplied by negative 25 plus 410. You get 210, right? Positive.
Yes.
So 210 EI. This is your final answer. But if you take a look at the illustration also, right? The illustration, you can see that this must be negative because it will deflect downward. So when you get negative 720 EI, which means that your answer is logic. And then the slope at A. Slope at A, right? You can see this is the slope increasing, right? So the theta at here, you get 210 over EI, positive, which means that your answer is also logic. Am I right? Logic, right?
Yeah.
Okay. So I don't think we have time to do the last example, but nonetheless, I think my main objective has been achieved. So I think Friday, we don't have to do any class. Is it okay? Because we only left one more example to go. So I'm confident that the next class, during our physical class, I think I will be able to cover it. Is it okay?
Of course.
Okay, so Friday, there will be no class. Before I dismiss, any question regarding today's topic, C7L2?
No.
No question, huh? So maybe I will just do one more replacement class next week just to cover up the tutorial for chapter 5 and also chapter 6 because we haven't do tutorial chapter 5 and tutorial chapter 6, right? So the online class, we will just cover the tutorial. The main lesson we have complete for chapter 7. No, not yet. We have C7L3 to go. So I think should be okay. So next week, we will try to finish up C7L3 and also enter the last chapter, chapter 8. So any question before I dismiss the class?
Just to
Thank
check.
you, Jackson.
Yeah, someone you have question, yeah?
For test 2, 5, 6, 7, right? Chapters.
No, I repeat many times already.
Okay.
Anyone can answer this, our friend? Test 2, which chapter?
It's okay. It's on the group.
Yeah?
It's on the group. It's on the group. But just checking again.
This is in the group. Just check again, correct. And even in the class, I repeat many times already. Test 2, only which chapter?
5 and 6.
5 and 6 only, correct. But there is 3 questions, right? So chapter 5, it will be question 1 and question 2. Chapter 6 will be question 3. Any other question?
No, thank you.
Okay, if there's no question, you may dismiss. If you ever scan the attendance, I don't know whether it's still working or not, the QR. If it is still working, you may scan your attendance. Wait for a while. I wrote too much, so yeah, PowerPoint's a bit hang already. Wait for a while. Okay. Don't know whether it's still working, but you may try. QR. Oh, sorry. It's not working anymore. So for those who didn't scan the attendance, I'm sorry. You are not able to scan anymore. All right, so thank you so much. I'll see you next week. So happy holiday. Merry Christmas for those who are celebrating Christmas. For the rest, happy holiday and have a good rest. Have a good rest during your holiday. Thank you so much. I'll see you next week.
Thank you, Doctor.
All right, welcome.
Thank you.
Welcome.